Welcome to Summarize Science. Today, we're diving into a fascinating paper about fusion energy. Fusion reactors, like stellarators, promise clean, nearly limitless power by recreating the process that fuels the sun. But one of the biggest challenges is handling the exhaust, plasma that's hotter than the sun's core. Think of it as designing an exhaust pipe for a star. This paper presents a brand new way to design this critical component, called a divertor, for complex, twisty stellarators. The problem with stellarators is that their complex magnetic fields can make the exhaust region chaotic and messy. Previous designs often struggled with this, leading to fuzzy boundaries that are hard to control. So these researchers had a clever and counterintuitive idea. Instead of trying to make everything smooth, they decided to design their magnetic boundary to have sharp corners on purpose. You're looking at it here. They call it the rotating lemon. The goal was for these sharp, continuous edges to act like a gutter, cleanly guiding the hot plasma exhaust away from the core. And the results were incredible. This 3D image shows the magnetic field lines forming the divertor that resulted from their lemon design. You can see these beautiful, well-separated divertor legs that channel the exhaust away. This structure is much cleaner and less chaotic than what's seen in many existing stellarators. Crucially, they achieved this using modular coils, which are much simpler to build and install than the continuous, helical coils used in some other devices. This is where the difference really becomes clear. On the left, in panels A and C, you can see the clean, orderly magnetic surfaces from their new design. Now look at panel B on the right. That's a diagram from an existing experiment, the Large Helical device in Japan, and you can see how much more chaotic and messy its exhaust region is. This paper proved that all that chaos isn't a necessary feature for this type of divertor. So, let's recap the big takeaways. First, it's possible to create a high-performance, low-chaos stellarator divertor using simpler, modular coils. Second, the key was a novel design approach, targeting a plasma boundary with sharp corners, like their rotating lemon. This is a significant step forward because it combines the advantages of a highly effective divertor with the practical advantages of easier-to-build coils. For the future, this could lead to more efficient and practical stellarator power plants. The next big challenge for the researchers is to integrate this brilliant divertor design with a plasma core that's optimized for holding in heat. If they can combine the two, it would be a massive leap towards making fusion energy a reality. Thanks for watching Summarize Science.